Hello grade 12s, welcome to my channel. Let us have a look at this question paper entirely. I did show you question 1 and the last question on current electricity, but then I didn't have enough time to look at the rest of this paper. So to avoid having too many videos on just one question paper, we're just going to do it from start to finish. Please folks, read instructions carefully, ensuring that you understand all of them. And of course, instruction like number 7, number 8, number 9 are to be committed to memory each time one sits for an exam. And remember, given an opportunity to explain something, you can actually use anything from a formula to a calculation or whatever that is applicable. So question 1 is the MCQs. So 1.1 says a horizontal force is applied to a crate, causing it to move over a rough horizontal surface as shown below. Now if you're causing something to move, we are literally talking about the influences of Newton's second law of motion. Right, the kinetic frictional force between the crate and the surface on which it is moving depends on. Now some of us know that Fk is equal to mu k times the normal force. So this can be very useful. Now the question says, does the kinetic frictional force depend on the applied force? It has no relation. How fast the crate is moving on the surface? Not necessarily. The surface area of the crate in contact with the floor? Well, that's not necessarily the case, because even if we place our crate on that corner, all its weight will transmit right down on that corner. So in the end, we will have the same normal force. Now the upward force exerted by the surface on the crate. Now this is somewhat a description of the normal force. Spare that it is not said that it is perpendicular to the surface. We need that part as well. So this is the missing part. Either way, this is somewhat an acceptable answer, as it is better than the rest of the options. Now 1.2 says two forces F1 and F2 can be represented with a single force of 8 newtons. And we know that this is the resultant force, because this is a single vector which has the same effect as 2 or more vectors acting together. So guys, definitions need to be understood well. Now if the magnitude of F1 is 3 newtons, which one of the following can be the magnitude of F2? So we need two scenarios, guys. We need the minimum resultant, as well as the maximum resultant. Okay, minimum happens when the two forces oppose each other. This being the 3 Newton force, and the maximum we achieve when the two forces act in the same direction. So that is the 3 Newton force. And of course the resultant is going to be within that range from minimum to maximum. So when we have the 3 Newton force, our maximum here becomes 6 newtons. Our minimum becomes 0, and our maximum becomes 6. Can you see that range? 8 is outside, so it cannot be 3 newtons. What about the 4 Newton force? Now, if we put the 4 Newton force, our resultant here becomes 1, and here it becomes 7 again. That range excludes 8 newtons, so it cannot be. Work it out some more. What about the 10 Newton force? Well, we get a minimum of 7 newtons and a maximum of 13 newtons. And this range includes the 8 Newton force, so this is possible. What about the 13 Newton force? So this gives us a minimum of 10 newtons and a maximum of 16 newtons. As we can see, this range excludes 8 newtons, so our answer is C. So those of you who were lucky to see the video that I produced on a question paper of November 2005, this idea was well explained there. So it must have been an advantage to those who saw it and even paid attention, because I know most of you, when something is too old, you think it's not applicable, and that's where you all miss the point. New things are not necessarily so good. In fact, they are almost useless. But these old things, remember, these were carefully constructed, so they will transcend times. So never be misled by people who keep talking of outdated things. Outdated by whose standards? Anyway, 1.3 says, two hypothetical planets, X and Y, have the same mass, right? The diameter of planet Y is twice that of planet X. Now we can see already we're talking Newton's law of universal gravitation. If the acceleration due to gravity on the surface of planet X is g, then the acceleration due to gravity on the surface of planet Y will be. So if we're talking about planet X, we know that g is big G times mass of the planet, in this case is x, over the radius of that planet squared. Now, when we talk about planet Y, our G is going to be big G, M. Since they are identical in mass, we're going to use mx. And then R here is going to be 2 times the radius of planet X, as is the case there. If we continue, we'll see G mx divided by 4r squared. For us to be able to compare this to the above, we need to factor out this quarter. We end up with G mx over r squared. And we know that G mx over r squared is just G. So this tells us in planet Y we will have a quarter of G. So this is one of those questions you just have to work out the answer. There's no knowing it without some working out. So 1.4 says a ball is thrown vertically upwards into the air, and we are to ignore the effects of air friction, in which case, if this is applicable, we are talking about VPM, vertical projectile motion. Here, the only force acting is the gravitational force. Now, the net force acting on the ball, hate that word net. I still prefer the resultant, but hey, who cares? Okay, this net force acting on the ball, when the ball is at its highest point, it's the gravitational force. So it's not zero. It's equal to the weight, because that's the force of gravity. It's not less, it's certainly not more. So B is our answer. So 1.5 says, or asks, which one of the following statements is always true for inelastic collisions in an isolated system? Now, isolated system, we know linear momentum gets conserved, but the type of collision is somewhat different. With inelastic collisions, kinetic energy is lost, or at least not conserved, whereas in an elastic collision, kinetic energy is conserved. So the statements are both momentum and kinetic energy are conserved. It's certainly not both, only momentum. Both momentum and kinetic energy are not conserved. Again, it's not both, it's only kinetic energy. So that's out. Momentum is conserved, true. But kinetic energy not conserved, that's also true. So that statement holds. Kinetic energy is conserved. No, it's not. Momentum is not conserved. Again, that's not true. It is actually conserved. So C is the answer. Okay. Now, 1.6 says an object moving horizontally at constant velocity. Now that statement already tells us that our resultant force here is 0, and also says acceleration is also 0. Now this suddenly encounters a rough horizontal surface. The object continues to move over this rough surface, and of course we understand that we will experience kinetic frictional force because of the roughness of the surface. Alright, question says which one of the following statements is correct? The net work done. Now we know that net work done is done by the resultant force. But now what is our resultant force? Initially we had 0. Now when we had kinetic friction, it becomes the resultant force. Okay, the net work done on the object during the motion over the rough surface is, it's certainly not 0 because it's done by an existing force in this case. Is it positive? Well, friction opposes the motion, so it's not positive. It is certainly negative because this is work done against the motion of the object and not necessarily constant, so C is the correct answer. Again, this goes with knowing what friction does to a moving object. 1.7 says the hooter of a car emits sound of constant frequency as the car moves away from a stationary listener. So we're moving away and the listener is stationary. So we know Doppler effect will tell us that the frequency will appear to decrease if the car is moving away. Okay, so which one of the following properties of the sound heard by the listener will not change? Okay, is it the speed? Well, we know that a speed is assumed or presumed to be a constant of 340 meters per second. So yes, anything constant is not changing. Frequency actually does change. Both frequency and loudness, they both appear to decrease. In fact, the loudness decreases, but the frequency will appear to decrease. Both wavelength and frequency, these ones are inversely proportional to each other. So against a constant speed, with this equation, V equals lambda, or frequency times lambda. We know that with this guy as a constant, these are inversely proportional. So in essence, as this one increases, that one decreases and vice versa. So, well, those change. So our answer here is A. Again, guys, knowing these definitions and concepts is very important. Now 1.8 says two point charges, each with charge plus Q. So they are equal, they are identical in magnitude. Now these are placed a distance d apart, okay? Now the force experienced by each point charge has a magnitude of F, okay? So this is using Newton's third law. Now the charges are now both doubled. So if we double the charges, what do we know? We know that the electrostatic force F is directly proportional to the product of the charges. Now if we double each charge, it means we are quadrupling the force. Right, so, and the distance between them is halved. Right, we know that the force F is inversely proportional to the square of the distance. So if we have that, we are literally quadrupling again the force. And these two we multiply with actually implies 16 times the force. So D should be the answer there on the magnitude of the force experienced by each charge after that change. Okay, so one can use the hypothetical equation using Coulomb's law, but the proportionalities can quickly lend us to the answer. 1.9 says in the circuit below, the switch is open. All right. Now the reading on the voltmeter is, so this is the voltmeter. Now as we can see, our switch is opened over there. Now it means the circuit is broken. And once the circuit is broken, this suggests there's no current flowing through the circuit. And reading the potential difference across the ends of that broken circuit is as good as reading the potential difference across the terminals of the battery. And that should read the EMF, because this is another way of just showing the definition of EMF using a schematic diagram. So this should be C. Again, you may ask, why not 0? It only becomes 0 when this circuit is complete, meaning there's current flowing in the circuit. From Ohm's law, the V is equal to IR. Well, we will have I, but R is 0. Why? Because we know the resistance of the connecting wires is negligible, meaning it's too little to be significant. So it's as good as nothing, and it only becomes 0 when just one of them is nothing. We don't want 0 times 0, right? Because that doesn't make sense at all. Why would we multiply nothing to nothing? You get it? So think about that in that manner, I suppose. Right, so 1.10 says, in the circuit below, the battery has an EMF E and internal resistance R. Excuse me. With switch S open, now we know that this means that circuit is out, that connection is out. The readings are registered on the ammeter and voltmeter. Okay. Right, so that's it. Now the switch S is closed. Okay, so we know that essentially the current will split into that segment and that segment, and of course it comes together here and completes the circuit. Now with a parallel connection, what do we know? We know that the effective resistance is decreasing, right? And if that's the case, it means the current should increase. Right, that's the best we can say so far. Now, how do the readings on the ammeter and voltmeter change? So this is this dude and this dude. Okay, so we saw that essentially, since we are dropping the effective external resistance, the ammeter here should increase in its reading. So this already eliminates options C and D. But now the question is about the voltmeter reading. Well, V is equal to IR. Now we saw that R is dropping while I is increasing. Therefore, it means V is indeterminate. We cannot tell what's going to happen with just that equation only. But if we take the partners in crime together, E is going to be I times the external resistance plus I times the internal resistance. Now we saw I is increasing, whereas R decreased there. Now here, we start to see what happens, because R is a constant and E is a constant. An increase in I will increase the lost volts. So the lost volts are increasing. If the lost volts are increasing for the same EMF, it means the external voltage available will be less. So that should decrease. So our answer is B. So folks, again, this is one of those questions in the long structured questions where one could be afforded an opportunity to justify certain changes when certain changes occur in the circuit. Again, as I often say, MCQs are the window to the long structured questions. Sometimes you can go there to remember something if you can't answer an MCQ question related to that, or use the MCQs if you were able to answer that, to then try and figure out how to answer that question in the long structured questions. Anyway, that should be easy. Now let's move on to question 2. Now question 2 reads, a block of mass 15 kilograms is pushed up an incline with a horizontal force F. Okay, not quite a common situation, but if we look at the structure itself, as we can see, this force will perhaps transmit to that point. Now, as this force is applied in that manner, this means this edge of our block will end up aligning with that point like that. So obviously, this block is expected to move up like that. But as soon as this vector hits directly to that mark, when the edge of our block is right over there, we don't know what will happen. Will it fall back? Will it continue to move? Will it stop? Only God knows. But for now, we know that the movement by this force of that block will only have that influence for just that period. Anyway, so it says the incline makes an angle of 30 degrees with the horizontal. The coefficient of kinetic friction between the block, can you see we're still talking kinetic friction as we have spoken about it in the MCQ sections. So that coefficient is 0.20. Remember, it does not have units. It's a ratio of forces there. Right, so the first question says define kinetic frictional force. So if you guys make a habit of understanding these concepts and these, important points, it is easier to generate these definitions without really cramming them. But again, you do as you are told, perhaps it works. But for me, I never struggled to find a definition because I made sure I understand what I'm dealing with, and so I could just generate the definition. Yes, I would not get full marks all the time, but I would never get 0 either. So let's see, what is kinetic friction? Well, we know that it is a force that opposes we can say it's a force that acts parallel to the surface on which, it's a force that acts parallel to the surface on which a moving object is in contact with, so that it opposes the motion of the object. Okay guys, so there's many ways you can phrase this. Either way, if the science is not lost, that's very important. What is important is that this force acts parallel to the surface, right? And this is, again, involving a moving object, okay? And this force opposes the motion of that object. So these are the most important points to ensure that in your definition you capture. Either way, there's many ways of even stating those, so do not be limited to just how I am phrasing it out, or any document you have read says. If you have an understanding and you can express it in words, that's good enough. Now 2.2 says we need to draw a labeled free body diagram showing all the forces acting on the block. That's easy. If we say this is our incline, we will see that we have a vertical force straight down. That is Fg. Well, we know that object moved up, so this is going to be kinetic friction, Fk. And we will have our horizontal force. It was said to be F. Of course, we don't need this one anymore. We just needed to get the slope right. And of course, there will be a force perpendicular to the surface, okay, on the object, which is the normal force. So guys, those labels are recognizable in physics. You don't need to write them in full unless you want to, okay? But if you use unusual or unknown labels, then you may have to justify what those labels stand for through provision of a key, or just simply write everything in full if you will. That's honestly your choice. So 2.3 says the block moves up the plane at a constant velocity. So if it is doing so, it means our resultant force is 0. Again, we got a question on the MCQs talking about a moving object moving at a constant velocity. So these kinds of things just keep repeating. So if you have not noticed the pattern, then I don't know what you are looking at. So 2.3.1, we are asked to state Newton's first law of motion in words. Again, if you look at that very first question, although it captures Newton's second law, but what happened before then? Exactly my point. So these laws are literally interdependent in a way. Well, we will say an object will resist any change to its original state of motion unless acted upon by an external non-zero force. Right, of course guys, the non-zero component for me is ridiculous, but you can say it sounds right. You know, some people overly emphasize points, but if we say there's an external resultant force, why did I say force? Non-zero resultant. Okay, so literally, if we say resultant force, we're already telling that this is not 0, right? Because if it is 0, then there's no resultant force. Great, so again, the resistance to any change of its original state of motion is key, right? And unless this is changed by some external resultant force. So that's the essence of the law of inertia here. We sometimes term this the law of inertia. Okay. 2.3.2 says we need to calculate the magnitude of the force F. Okay. And we can say it's 6 marks. So it's one of those, you can say higher grade or in between. type of questions where there's a lot of thinking that needs to come in. So how will we do this? Well, let's first look at these forces that are acting on this object. We've got our object here with the gravitational force coming down straight like that. Okay. Right. Now, this one has components. It has the perpendicular component and the parallel component. Hope this is parallel, but let's do it anyway. It's not exactly parallel, is it? Not at all. Even this is not perpendicular. Okay, so let's try again. Still not perpendicular. That's a bit better. All right, we want to just get some stuff in the right orientation, just to make it nice. Of course, we've got the time. We've got the time, so if you don't, too bad for you. Right, so we've got those components of the gravitational force. This becomes Fg perpendicular. And this becomes Fg parallel, right, with Fg there. Maybe let's change the label to avoid trouble. Great, so we've got the frictional force going down. We've got the normal force there. All right, now we will have this force, the applied force, right? Right, so this applied force has its components as well. Remember the main components, others are useless, honestly. The main ones is usually the vertical and the parallel, because those ones have an influence in a lot of things. So this force itself will have, it will have the vertical component and a parallel component. Of course, you can just sort this out a bit. So please be in the habit of showing all these forces. Remember that force becomes the resultant of those components. And essentially they themselves are perpendicular to each other. Now we know the angle of the incline in the horizontal was 30 degrees. So will be the angle between the vertical component and the weight. And remember, for the weight Fg, that angle is always between Fg and the perpendicular component. Never ever miss that. Right, so this is the forces that we have acting on our body here. Nice, but now how do these ones help us? Well, we know that for the motion of this object, it's only the horizontal forces. So we will have the one that is horizontal upslope. Which one is this? This is F parallel, this is F perpendicular. So this is going to be F parallel. Now we will have two forces. We don't know which one is bigger and we don't care. We can say this is Fg parallel, that's Fk. So those are the three forces that are going to be responsible for the motion of this object. And we know that F parallel is related to F. So it should give us the magnitude of F. But then we have an issue here that, look, this Fk has not yet been determined. So how will we determine this? Well, we need to think about our body as well. That we have two forces perpendicular to the surface. We don't know which one is bigger, which one is smaller. So at the end, we don't care. So this could be F perpendicular, that could be FG, or vice versa. One way or another, they are facing down. And these ones will be balancing the normal force in terms of the vertical forces. Don't know why this doesn't want to be vertical. All right, so we know that, okay, the normal force here will then give us the frictional force at the end of the day. So this is quite a very hectic situation, but yeah, we need to deal with it. So we know, using Newton's second law of motion, the resultant force is equal to ma. You can even use that part that I just did. So what is the resultant force here? It's going to be F parallel minus the sum of Fk, or maybe let's start with Fg. Doesn't really matter which one we start with, okay? So we can say Fg parallel plus Fk is equal to ma. Now, this implies, what is F parallel? Now, F parallel is on adjacent side of the angle, so that's the cos. So this is going to be literally F cos 30 degrees minus, now this one is a bit complex, Fg parallel is going to be 15 times 9,8 times the sine of 30 degrees, right? Using the second triangle. This, we add the frictional force. The frictional force here is going to be 0,20 into the sum of these two forces. Now this is going to be F parallel, F perpendicular. It's on the opposite side of that angle. So that's going to become F sine 30 degrees plus 15 times 9,8 times the cos of 30 degrees, right? Close that. Okay, it looks like we need to move things a bit back. So that we can have enough space to write our equation in full. So this is going to be 15 into 0 because there's no acceleration. Now this implies, now we know, folks, that this has F in it and this one is going to have F in it. So those will be like terms. Now let's see, cos 30 is root 3 over 2, which is literally 0,8 some change. Let's see, cos 30, 0,866. So this is 0,866 times F minus, we want to bring in that 1. Okay, so this is going to be 0,20 times sine 30. Right, so that's 0,1. Okay, so we've got 0,1 F. Now these two are going to be like terms. But remember, this one is dragging this guy as well. Okay. So we're going to add those up. So we've got 15 times 9,8 times the sine of 30 plus 0,20 into 15 times 9,8 times the cos of 30 Right, our answer here is minus 98,9611, just to avoid problems. So this is going to be 0. And of course, this implies that if we say this one, this is going to be 0,766f is equal to 9611. Actually, we can just avoid this situation here and just put it down here. This is going to be divided by 0,766. Therefore, our force is, we divide what we had by 0,766, get 129,19 newtons. Remember, unit of measurement must show. If it is not, we lose a mark. Okay, now we were talking magnitude, so we don't need to worry about direction. But if we have to consider direction, this is horizontal to the left, or we can say west, or one can even say at 270 degrees. Right, so this is done. Very complex calculation, but if you understand its components, this is easy. We can get a mark for the formula. Determining this is key. This whole thing is key. Knowing that our acceleration is 0 is also key. 2, 4. Then we can say the general substitutions is the extra mark and the last mark. If the unit is included, we get those 6 marks. Okay, easy. So let's see 2.4. We are told that a satellite that is 1,000 kilometers above the surface of the Earth is accelerating towards the Earth. If the weight of the satellite at 1,000 kilometers above the surface of the Earth is 3,800 newtons, calculate the weight on the surface of the Earth. Okay, so for us to find the weight, we need the mass of the satellite. Well, this is easy. It's Newton's universal gravitation issue here. So this is Fg equals G, m of the Earth, m of the satellite, divided by r squared. Now if we just draw a schematic diagram here, this is the Earth with its center, radius. Now we've got a satellite here. Right, this satellite is at 1,000 kilometers above the surface. So that means the distance between them is going to be the radius of the Earth plus that 1,000 kilometers. Easy. So this implies that 3,800, not 8, is equal to big G is 6,67 times 10 to the minus 11. Is that so? Let's just check it. Sometimes these constants are not so easy, but if you've worked with them nicely, you are good. Okay, maybe let's stay here because there's a lot we need from here. Great. Mass of the Earth is 5,98 times 10 to the exponent 24 into the mass of the satellite, which is what we want, divided by the radius of the Earth is this one. So this is 6,38 times 10 to the 6 plus 8,000 kilometers, basically 10 to the 6 meters. Then we square this. Now folks, following cross multiplications and our gymnastics, we know that the mass of the satellite is going to be 3,800 times 6,38 times 10 to the exponent 6 plus 10 to the 6 all squared divided by 6,67 times 10 to the minus 11 into 5,98 times 10 to the 24. Therefore, the mass of the satellite is, let's see, we've got 3,200 times 6,38 times 10 to the 6 plus 1 to the 6 all squared divided by 6,67 times 10 to the minus 11 into 5,98 times 10 to the 24. Right. So what we get is 518,88, let's say 3 kilograms. Okay. We can say then we know that the weight of the satellite on the Earth is going to be mg, which implies that, remember, this is small letter w, not capital letter W, so it's going to be m, which is 518,883 into 9,8. Therefore, the weight of the satellite is, we multiply that by 9,8, we get 5,085,05 kilograms. No, newtons. Oops. So that's the calculation. So, very easy stuff otherwise, as long as we understand what we need to do. So, we normally get a mark for this dude, for the substitutions, and the answer. Here we can mark the method and the answer. This is how many marks? 5. Yeah, that's good enough. That's good enough. So, those are the 19 easy marks of question 2. Okay. So I hope you guys were following well. If you have any questions, please shoot. Great. So let's get to question 3. Now, question 3 reads, a ball of mass 0,5 kilograms is dropped. Now, when something is dropped, we know that its initial velocity is 0. This is dropped from a height of 1,2 meters onto a hard floor. it bounces to a maximum height of 8 meters. The floor exerts a force of 50 newtons on the ball. Okay. So if we can just picture the scenario, we've got a situation here. The ball is here, it's dropped. It's going to be a parabolic little thingy. If we think about it as a function of time. And it will collide with the floor, whether it's an instant rise or there's some time lapse. We don't know, so we can just assume that it just immediately rises, unless we hear something as we go on. Okay, so technically this would be the height, which is 1.2 meters. Okay, so that's what we have. Now we are to ignore the effects of air friction, so we are doing VPM. We know the only force acting here is the gravitational force. All right, so first question says we need to write down the magnitude and direction of the force that the ball exerts on the floor. Well, if the floor exerts 50 newtons, the ball exerts 50 newtons using Newton's third law. So this is going to be downwards. Of course, the reasoning here is Newton's third law. Now you may ask me, why not the gravitational force? Because the only force acting on this ball was the gravitational force. Now when it hit the floor, why is it not the gravitational force on the floor? Now that is very interesting, because remember guys, what is the gravitational force? Who's acting on the ball? Due to gravity. It's the center of the earth, not the surface of the earth. So that force is the force that is exerted by the center of the earth, not the surface. So if the surface is causing this much, then the ball is also causing that much, while the earth is also doing its own thing. The only problem is that when there's an intervening surface, there's a bit of an issue. This is why I don't like these questions, because they can cause unnecessary strain to students. But again, I don't know how teachers teach. But for me, if teachers are confident they are teaching the right thing, it's okay. But for me, it's a bit of a controversial question, I guess. But at the same time, it's very strange. It's really very strange. But let's leave it at that. Let's leave it at that. We can justify what we're doing. Wrong or right, you will see on the memo, guys. This question paper actually has a memo attached, so you can go and peruse for the answer there. But if we are right, or good. If we are wrong, you will see there what's going on. But the sad part is that usually with these memos, there's no explanation as to why the answer is what is proposed. Anyway, you figure it out. 3.2 says calculate the velocity at which the ball strikes the floor. Now, we want the velocity. So this is 3.2.1. Well, we've got the height, and we know the initial velocity is 0. So we don't need the equation with time. So we can say the final velocity squared equals the initial velocity squared plus 2g delta y. So this implies that the final velocity squared is 0 squared plus 2 into 9,8 into 1,2. Of course, guys, we are taking down as positive, so usually choose the direction of motion. Let's say the direction of the original motion is positive, but if there's an up and down movement, I often choose up as positive. But again, No one is actually forcing you to choose what direction you decide. Okay, so the ball is being displaced down. Acceleration due to gravity is down, so everything is positive. So this implies that our final velocity is going to be the square root of essentially 2 into 9, 8 into 1, 2. Therefore, the final velocity is what we will have there. So 2 into 9, 8 into 1, 2. And we take the square root. We get 4, 8, 5 to 2 decimal places, meters per second. Now remember, question said velocity. So velocity is a vector. So this is downwards. Okay? If this is not part of the answer, guys, the final mark is lost. So we often get a mark for a formula, substitutions, answer. Okay. Another person may think of giving the mark for the initial velocity because it took knowing that it's going to be 0. Okay. Either way, 4 marks. Is it 3? Okay, so I'm a bit overzealous here. All right. Nice. So it looks like we only get 1 mark for both magnitude and direction. Okay, so 3.2.2. We need to find the time taken by the ball to reach the floor from the moment it is dropped. Okay, so so guys, usually I avoid using an answer that I got above just in case it is wrong. But again, you guys have what you call positive marking, so in a way you are protected somewhat. But I think it's wrong. This positive marking thing must not exist. If you screw up the top, sorry for the language, everything is a mess, okay? It cannot be taken as true. Anyway, so let's have a look. So in any case, the final velocity equals initial velocity plus g delta t. This one becomes easier to work with. So this is 4,85 equals 0 plus 9,8 delta t. Okay, so this implies that our delta t is going to be 4,85 divided by 9,8. So our time is going to be what we have there. So it's 4,85 divided by 9,8. We get to 2 decimal places 0,49 seconds. I often put my S in brackets because I always feel it looks like a 5. So yeah, whatever. So guys, formula, substitutions, answer. As I said, yeah man, this question was 4 marks, my lord. Maybe let's give this mark. How did I miss this? Knowing that, it's good enough. Yeah, that should be 4 marks or 2 marks for the answer, because direction is key as well. Okay, so that one is done. But guys, you can still use this formula. Delta y is going to be the initial velocity delta t plus half g delta t squared. The only problem here is going to force you down the path of the general quadratic formula, which is not provided in the information sheet. So if you're a student who doesn't know maths so well that you can remember it, you are dead here. Okay, but if you do remember it, can use it. So remember, this is going to force you guys to using, we're looking for time here. It's going to be delta t is going to be minus b plus or minus the square root of b squared minus 4ac over 4a2a. Right? And the answer here, you choose the positive answer. Right? Never choose a negative answer unless it's the only answer that we get. Then we have to ignore the sign. But when we get a positive and a negative, the positive answer is the correct answer. The negative answer is not the answer. We never have negative time, do we? All right, so that's easy, guys. So I've highlighted what you could do to just enjoy that exercise. Use the other equation and get yourself into the same answer. At least you will know if you've got it right or you did not. 3.2.3 says we need the speed at which the ball bounces off the floor. Easy. Again, we've got that height, which is 0.8. We know at maximum height the final velocity is 0, so we can sort this out. Final velocity squared equals initial velocity squared plus 2g delta y. Now this implies we know that the final velocity is 0. Initial velocity is what we want. 2 into 9.8. We chose down as positive. But now this displacement is upward, so it's going to be minus 0.8. This is where the students get caught pants down. So don't be one of those students. Okay, we know that the initial velocity squared is going to be equal to, in fact, let's just do the gymnastics nicely. It's going to be the square root of 0 squared minus 2 into 9.8 into minus 0.8, isn't it? So therefore, our initial velocity in that scenario is going to be the velocity of bouncing off the ground. So this is as good as the square root of minus 2 into 9.8 to minus 0.8. So to 2 decimal places, I get 3.96 meters per second. Now the good thing is that the question said speed, so we don't need to write the direction. Okay. Although this as a vector is supposed to be upwards, or should we say negative, because of the choice of directions, but if it is saying speed, we present a positive answer. Either way, even if the question said the velocity, we don't need to write the negative before the answer. We just need to write the direction. We never present negative answers. Okay? Never do it. But account for the negative if it is there. Right. So 3.2.4. We need to find the time that the ball is in contact with the floor. Okay. I would say this is a higher grade question because the best way we can hit this one is using the impulse momentum thingies. And again, it takes understanding the topic to know that actually it can be used. And if you've seen some videos I've shown you guys, be it from IEB 2020, 2020, yeah. I think there's some physics videos that I did of questions from 2020 or so. You will see that this thing is applicable there. And many others, you know, from the Free State, Term 1 or so, there were some questions that I did, these kinds of things. So those of you who are really working hard and making sure the they take advantage of this channel, they certainly are going to score big marks. Although there's no guarantees, guys. If you don't work hard, this is just going to be a futile exercise. Even I would look like a time waster. But again, if one or two makes it because of this channel, I'm so ever happy, because obviously I cannot change this country, but I sure can change one or two individuals. Anyway, let's have a look at this question. What are we going to do? We will use our friend. Right, and do not feel afraid that we are not yet on that topic. No. Physics, like maths, guys, concepts of any component of physics or physical science can be tested. You may even be surprised to find issues of chemistry someday needing to be used in a physics question, and vice versa. So do not take this for granted. I promise you. Anyway, whether you understand or you don't, it's up to you. But just know, folks, this theorem talks about the resultant force. It's not just any force, it's the resultant force. This is literally Newton's second law, but in terms of momentum. Okay, so the resultant force, remember, we were told that the flow exerted on the ball 50 newtons up. But we also know that the center of the earth is exerting the gravitational force. So what is the resultant force? Therefore, it's the difference between the two. So we will know that if we chose down as positive mg, this is 0.5 times 9.8 minus the 50 newtons. Okay, we don't need the unit. Times the delta t is equal to, the change in momentum is going to be the mass into the final velocity. Remember, the final velocity here is going to be the velocity with which it bounced off. Now this is a velocity and it was up, so it should be negative. So this is minus 3.96 minus the initial is the one that it hit the ground with, which is going to be 4.85. So this implies that our delta t is 0.5 into minus 3.96 minus 4.85, all divided by the 0.5 times 9.8 minus 50. Therefore, delta t is what we get. Let's see, what do we have here? 0.5 into minus 3.96 minus 4.85, all divided by 0.5 times 9.8 minus 50. Okay, so to two decimal places, I am getting 0.10 seconds. Okay, usually it's a split second. So yeah, we can accept that answer. Right, so we know this is a mark. Calculating the resultant force is another mark. The right hand side should be a mark, the change of momentum. And the final answer. Okay, so that's easy, guys. Not a difficult question either. Right, let's handle 3.3. 3.3 says, sketch the graph of position versus time representing the entire motion of the ball. Use the ground as zero reference. Right, easy. So we know this is going to be a position versus time graph. of the ball, right? We must always provide a topic or a heading, right? And then we can do the things that we need to do. So we know this is our time in seconds. This is going to be position in meters. And we started at 1.2 meters. And of course, our graph is going to be parabolic as a function of time. Then there was this collision time right there. And then it goes to that maximum height. Okay. So we know that we need to showcase this. As 0.8. So we need to show the height. We need to show the height reached after the bounce. The time at which the ball reaches the floor. This is here. So we got 0.49, didn't we? Okay, it looks like we're going to have a problem. Okay, let's do this first. So we know here this is 0.49, right? That's the time it hit the ground. Then there was a time lapse, which was 0.1, but we're going to add it to here. So let's just add it here. So this is going to be 0.59, okay? And of course, we will take it to the maximum height. Okay. So we've done it, guys. Everything is there. Okay, so the shape of the graph, any one of them heights, any one of them times, labeling the axis maybe, and the topic, 5 marks. Again, guys, it depends on how the marking guidelines are proposing the marks should be distributed. Either way, with the correct sketch, we get full marks, okay? Provided we have shown everything that is required. So this, guys, was a very nice and tasty 21 marks. I do hope you followed nicely and you were able to see everything. So if you have any questions on the comment box below, just type your question, or any that seeks clarification on any question we will have gone through here. But at the same time, you are not limited to just this. You can ask any related questions. Hear me? Related questions. I've had guys asking me things I don't have a clue about. I don't know what they're trying to do. Or perhaps they think I am some AI of some kind. I am not an AI, guys, and in fact, I'm not a smart guy. I'm just a hard worker, that's what I am. And of course, a fanatic at best. I'm not an expert of anything. So yeah, don't be fooled by perhaps my way of doing things and start to believe that I'm actually smart. No, I am not. I never was, and I never will be. But one thing for sure is I can give the smart ones a run for their money. That's what I enjoy, causing chaos, if not progressive chaos, of course. Anyway, let's look at this question 4. So question 4 says, a bullet of mass 6 grams is shot horizontally onto a 194 gram wooden block, which is at rest on a horizontal surface. The bullet hits the block with a velocity of 200 meters per second and remains stuck in the block. And we are to ignore the effects of friction. So what are we creating here, guys? A closed system. We are creating a closed system. But some people will go around saying an isolated system. My question is, in the physical science field, is there a difference between the two? Well, we can argue about that. But for me, conceptually, there is no difference. And essentially, I don't see the point of trying to separate the two. Anyway, whatever it is that you have in mind, by all means, indulge yourself. Right, 4.1 says, state the principle of conservation of linear momentum in words. Okay, that's good. So 4.1, we know that total linear momentum in an isolated system remains constant. Okay, now you may ask, why didn't I say closed system? Well, I just chose not to say closed system. I could have said closed system, and I would dare anyone try to mark down my student for saying that. If it happens, please call me in front of your teacher, of course, so that I can have a word with them. Right. Anyway, I am a daring freak, so yeah, I'm not afraid of anybody, even danger. When I am faced with it, I forget about my fears. I may be afraid before the danger hits, or if there's a possibility of it, but I often confront it, and what happens? Nothing. If at all, I become victorious. So don't try me. Please, some brief, I beg you. Anyway, basically, guys, the cornerstones of this topic, of this definition, is that this should be total linear momentum. And we need to hear something about an isolated system or a closed system. Whichever you choose to use, there's no issue. But anyone who tries to say different, when you're dealing with them, deal with them in the manner that they require of you. Don't be resistant. Don't be crazy. I know I can be crazy, but you, on the other end, you are not at liberty to be rebellious, okay? Unless you can sense a healthy student relationship with the teacher, where the teacher allows you to express yourself, even in ways they have not taught you. Because, yeah, those kinds of teachers are the golden teachers that allow students to freely express themselves in the subject with everything that they have come across, and of course, be the stewards in this case, folks. Students are still going to pick up crazy things all around them. You are to facilitate that acquisition of knowledge. Whatever they bring, give constructive criticisms or constructive corrections. But don't be selfish. It's not about you as a teacher. Don't go around telling them, I know I always scare my students when they tell me, with exponential expressions. Whenever they start saying to the power, I throw a fit. I certainly go into a seizure, and they laugh at me, and then they're like, oh, sorry, we meant to say. I'm like, I'm joking, guys. You are free to say whatever rubbish you want to say. I'm not the guy who's going to tell you what to say, when to say it, and how to say it. I can only suggest the best way of putting things so that you yourself look like a force to be reckoned with rather than a joke. Okay? Because this is upon you, of course, students, to learn things that make you look better, or you learn things that make you common. It's up to you. Anyway, it was not about that, by the way, so don't read too much into my commentary. When I'm tired, this is what I do. I talk too much. Sometimes I say more than I'm supposed to. Anyway, calculate the speed of the block bullet system immediately after the bullet stuck to the block. So this is going to be the sum of momentum before equals the sum of momentum after collision, right? So this implies, now we need to change those masses from grams to kilograms. So 6 divided by 1000 is 0,006, right? So this is 0,006 into, of course, we can choose to the right as positive. And then this is going to be 200 plus, the block is 194, so this is 0,194 into 0. It was stationary, right? Right, because we're saying it is at rest. I missed to highlight that part. Is equal to, now these ones got stuck, so their masses are going to add up into one whole mass, and their velocity will be the same. So this implies that the final velocity of these two is going to be basically 0,006 into 200. Is it divided by? Yes. 0,006 plus 0,194. Therefore, the final velocity there, 0,006 into 200 divided by the sum of 0,006 plus 0,194. We get 6 meters per second. Now the question said speed. So speed is a scalar quantity. No need to mention direction. Alright, so using the law of conservation of linear momentum, we can say safely substitutions to the left, substitutions to the right. The final answer. Excellent stuff. Right, so usually this is a very easy section of physics. Usually here this is free marks. It's like calculus in paper 1. All students know that this is where they just pick up marks. Differential calculus is easy, guys. In fact, calculus as a whole is easy. I don't care who says what. Calculus is easy. Yes, you may want to make an argument and say, hey, you know, when you leave to do maths at a higher level than matric, it's not that easy. No, it's actually easy. If you look at all those issues you're going to have to deal with, it's nothing but these very basics put in there. And of course, some slightly more basics that they're going to introduce you in your first year in any mathematics course. After that, everything is going to circulate around those very basics put together into these big concepts. So at the end of the day, for me, I find calculus the easiest thing to think about in maths. But it's not complex. If you understand the rules, you are done. But if you don't understand the rules and your maths, your algebra is poor, you are dead, because calculus is playing with the algebra. Okay. Anyway, Algebra itself is nothing really as abstract as we often think, but these are things that can describe, real life phenomena. So at the end of the day, they're not so abstract. But again, we know they're not so perfect either, but they bring us closer to the truth. Anyway, let's not talk too much, guys. I know I have this tendency just streaking away from the main cause and end up making you guys tired. Okay, immediately after the impact, the block bullet system enters a rough section PQ. Right, once it is a rough section, we know there's going to be kinetic friction, which is 5 meters long before coming to rest. Can you see, guys? Question 1.1 is here. Now we need to calculate the acceleration of the block bullet system. And we know that this bullet will this system is going to come to rest. So this is easy, guys. Nobody dictated how we're going to do this. So we can just simply use equations of motion. So we know that the final velocity squared equals the initial velocity squared plus 2. Be very careful this time. The acceleration is not g. And the displacement is not y. So this is the story. Final velocity is 0. Initial velocity is that one we calculated above, 6 squared plus 2 into a. The displacement is 5 meters. So this implies that a is going to be 0 squared minus 6 squared all divided by 2 into 5. Therefore, a is, literally 6 squared divided by 10. So this is 3,6 meters per second squared. Remember, this would have come out negative. This means it's to the left. So we can say to the left. Okay? Or in the opposite direction of motion. We can just use an arrow pointing to the left. So there's many ways of denoting the direction. Again, the question said acceleration. So you need to think about direction here. So formula, substitutions, we can say, since this is a vector, it's good enough. Or we can consider the fact that the final velocity here is 0. Okay, 4,4. So 4,4 says a box of mass 60 kilograms. So this is a different story. You might as well just answer this separately. Okay. So a box of mass 60 kilograms slides down a rough incline. Again, there's going to be kinetic friction, which makes an angle of 25 degrees with the horizontal. Okay, it's indicated. The box experiences a constant frictional force of 180 newtons. Okay. Now 4.4.1. We are asked to draw a labeled free body diagram showing all forces acting on the box. Okay. All right. Okay. All right. So we've got the gravitational force straight down. Right. Then there's going to be a frictional force parallel to the incline. Since this is a moving object, it's Fk. And perpendicular to the incline will be the normal force. Again, guys, those labels are recognizable in physics. You don't need to provide for labels for those unless you want to. But if you use unusual notations, then you have to provide a key. Now the question says, write down the name of the force which does zero work on the box. So we know it's all perpendicular forces to the surface on which an object is moving or is supposed to move. They don't do any work. So this is going to be the normal force. Okay, can you see again in these longish questions? This was an issue with question 1.1. It was actually for us to identify the normal force. Now we're still identifying its impact. You get it? So guys, don't you see that you're asked one and the same thing all the time? It's like that. Okay, so 4.4.3. We are told that the box now passes point A at a speed of 4 meters per second before passing point B, which is 15 meters lower down the incline. Okay, so that is indicated. Now the question says, calculate the kinetic energy of the box as it passes point A. It's very easy. EK is half mv squared. This implies that EK is going to be half. The mass is 60. The velocity is 4. Therefore, our EK is 30 times 16. So we get 480. Remember, this is energy, so it's joules. All right, easy stuff. Formula, substitutions, answer. Guys, these are just cheap marks. This should be just 2 marks, to be honest. It's a grade 10 question. Why on earth do we have a grade 10 question here? I don't know. I don't understand. Calculate the magnitude of the resultant force acting on the box between points A and B. So we know there's 2 forces opposing each other there. If this is the body, we've got the frictional force to the left. We'll get Fg parallel downslope. So those are the 2 forces. So the resultant force is going to be because of those 2. So well guys, this is just 2 marks. We know that the resultant force is certainly going to be Fg parallel minus Fk. This implies that the resultant force is 60 times 9,8 times the sine of 25 degrees minus 180. Therefore, the resultant force is 60 times 9,8 times the sine of 25 minus 180 gives us a 68, to 2 decimal places is going to be 50 newtons. Now the question said magnitude, so we don't need to worry about the direction. Okay, easy stuff. I think the calculation of this force and the answer is key here. The rest is too easy. Again, this is another grade 11 question. In fact, a very basic. It's a class exercise. Why is it here? I don't know. Anyway, we need to state the work energy theorem in words. Well, we know that the total work done on an object is equal to that object's change in kinetic energy. This is again one of those easy, that the work done should be the total, right? And we're talking about the change in kinetic energy, so this is what is key here. So again, guys, some cheap 2 marks. This definition is supposed to be given 1 mark. It's inappropriate to give 2 marks for that. 4.4.6. We are now supposed to use the work energy theorem to calculate the speed of the box as it passes point B. Okay, so we cannot use equations of motion, okay? Well, we know that, by the way, the work here is capital letter W. We write, I hate that word net, but what can we do? It's there. Is going to be the change in EK. So remember, this is the resultant force, so this is going to be the resultant force times the displacement times the cos of theta equals half m, we've got v squared minus vi squared, okay? So the resultant force is what we calculated above. So this is 68,50 times the displacement is 15 cos. Now the resultant force is downslope. So essentially this is going to be cos of 0 degrees is equal to 0,5. The mass is 60 times the final velocity is what we want minus the initial velocity, which is 4 squared. Now this implies, well, that the final velocity is going to be equal to the square root of, we're going to take this 68,50 into 15 into 1, right? Cos of 0 is 1 divided by 0,5 into 60, and we're going to add 16 to that, right? Therefore, that final velocity final velocity at B will be the answer. So I just moved everything so that I can have an easy calculation. So we've got 68,50 into 15 divided by 0,5 into 60. We then add 16 there. So what we get here, to 2 decimal places, this is 7,09. 7,09 meters per second. Again, it just said the magnitude, the speed. So speed is a scalar, so we don't need any mention of the direction. And we know that it should be accelerating as it moves down. So that should be a higher speed. Right. So again, we get a mark for this or this, doesn't matter. You can say left hand side, right hand side, and the final answer. Okay, easy 4 marks, folks. Again, questions on momentum, energy, and power are usually as easy as it is the case with differential calculus. So it's a very easy topic. Important, but easy. All right, so let's move to question 5. So question 5 says a 200 watt motor operating at 85% efficiency pulls a crate of mass 90 kilograms up a slope at constant speed of 1,5 meters per second. So it means the resultant force is 0 and acceleration is 0. Now we are told that it takes 30 seconds to raise the crate from point X to point Y. So the duration from X to Y takes 30 seconds for the slope. Okay, right, off the slope anyway. Now folks, everything is nicely showed, so we can just show up with the answers. We need to define the term power. Easy stuff again. You know that it is the rate at which work is done. Right, it's the rate at which work is done. Again, this is illegal to give 2 marks. This is a 1 mark type of a definition. But anyway, you get rewarded for nothing. Calculate. So this means to answer these next few questions, we cannot answer them without some show of a calculation. We need to calculate the energy supplied by the motor to the crate in 30 seconds. So energy, we know that this is from the power being equal to work over time. Right. But this power, it's only 85% efficient. So this is 85 over 100 times that power, which is going to be equal to the work divided by 30 seconds. Therefore, work is 30 times 85 over 100 times 200. So this gives us 5,100 joules. Remember, this is energy. It should be in joules. So of course, folks, this calculation and the general substitution answer, I'm thinking, why is this 4 marks? Oh yeah, in physics we get a mark for the formula as well. Anyway, 5.2.2, which I think it's a sellout position, is it not? Come on guys, it's a sellout position to give a mark for a formula. Students have no excuse not knowing formulae, especially when they are supplied. Come on guys, you are spitting on the face of physics. I know I benefited from that myself, but the question is why? It's not necessary. Anyway, whatever. We cannot be too careful, can we? Right, 5.2.2 says we need to find the gain in gravitational potential energy of the crate. Again, Gravitational potential energy at X is 0 because it's on the ground. There's no height. So we know that gravitational potential energy is just mgh. Again, I don't know why a grade 10 question is asked here. It's really crazy. It's nuts, is it not? Excuse my choice of words, guys. I sometimes forget I'm supposed to be relatively professional, okay? Yeah. I should not be too careless with what I say because at the end of the day, I'm misleading the masses who come by at my channel. So I apologize for the offenses committed, folks. I do not do it intentionally. It's just my loud mouth getting the better of me. Anyway, this one, folks, is just a cheap 3 marks, which I'm like, why? But hey, I am not the examiner and you are the student. It's your job to answer every question, however demeaning that question is. It's 3 marks after all. Those 3 marks can actually maintain your distinction, which is getting lost, or a pass, which you're almost losing as well. Anyway, the last question here says we need to find the magnitude of the frictional force acting on the crate between X and Y. Can you see this frictional force story? Keeps on popping up. I told you guys. MCQs are the window of opportunity. Take use of it. Anyway, hey, we've got issues before, so we don't know the theta here. We don't know the theta. Also don't know the delta X. So bonak. Qale ngokukhamisa ngoku sendizawuthini. Vala umlomo. Ngidlo swabana biyano. What are we gonna do? Because folks, I know if I need the frictional force, technically for this to do constant velocity, there's these forces acting on the crate. One acting downslope is the frictional force. And I don't know which one is bigger than the other, and of course FG perpendicular. And this is going to be the force of the engine that opposes those. But now the sum of the frictional force, the kinetic frictional force, and the the parallel component of the gravitational force are balanced by the force applied. Okay. So this is the unknown. Now this means we need to find out what is that force. But now the issue is also going to come when we get here. This dude is troublesome because we don't know the angle. So it also says we need to find a way. It's either we find theta or we find delta X. Whichever comes first will help us. Now we gotta think. We got to think. And it feels like we need to start thinking about it really. What can we find, folks? Yeah, telling I think of the question if non pumpy sang. Anyway, guys, in physics is not an easy subject, by the way. It's not. Sometimes the way many questions are asked, I don't like because they can be asked a lot harder than they are asked lately. But even back then, anyway, let's not say lately. Yeah, what am I saying here? Now I'm a bit stuck, folks. I don't know what to do because I don't know things about this triangle, and I need to know things, at least one of the two, theta or delta x. Which one can I get to? Can I use the constant speed? Yeah. We know constant velocity. We know s is equal to vt, right? I've got the velocity. I've got the time, so I can find, oops, by the way, you don't use this formula. I don't know why they moved away from this formula. Were nice. They simplified the work. You guys use this one, delta x is equal to v delta t, right? Or you can say velocity is the change in displacement over change in time. I mean, whatever. All of these is one and the same thing. So we know that we can actually find delta x here using that piece. So first of all, we know that delta x is equal to velocity times delta t. Of course, guys, whether you write it this way or you start here, it does not really matter. I know some teachers will tell you, copy this as it appears on the information sheet. Well, what if I did not? So what? Yeah, that attitude will sink a careless student for sure. Because if you copy this, I mean, you write this wrong, then you don't get a mark for the formula. And it means your whole calculation gets botched. All you will get is substitutions as per the formula you wrote. Then you lose the mark for the formula, you lose the mark for the final answer. Yeah, that kind of attitude has those negative effects. But what if I have an attitude, but I'm also careful at the same time? So what? Nothing. All right? Okay. So this means delta x is equal to, we were told this is 1,5 times 30. So delta x here, 1,5 times 30 seconds is 45. Ooh, 45 meters. Now that can help us because look, FG parallel is just sine theta. Sine theta is opposite over hypotenuse. So we don't even need this guy. We don't need to work the theta. Just that ratio is sine theta. Nice and easy. Okay, we can say here then, I think we are ready to answer this question. Then we know that the resultant force is always equal to mass times acceleration. Now we can say upslope is positive or downslope is positive. It doesn't really matter, folks. At this point, we just move. We can say the force by the engine. Hold your roll. We also don't know that force. My God. We have a big problem also. Yeah, ne? Okay, but the work done by the engine, we know, so we can find out. Kanti kutheni ngole question ngathi ufuna ngiqala. Why? Also, we know that power is force times velocity, right? Yeah, because the rate at which work is done, remember work is force times the displacement, the cos of theta, divided by the change of time. Delta x over delta t represents velocity. So that's how we can derive that formula. So yeah, it's like this. So we can say we were told this is 85% efficient. So this is 85 over 100 times 200. We want the force, but the velocity we're told is 1,5. So we can say this implies that our force, maybe we can say FA, yeah, it doesn't really matter, guys. Anyway, we can say therefore FA is equal to, let's sort that out, I don't like it, 85 divided by 100 times 200, it's 170 divided by 1,5. This question, I think we need to move down with everything. Divided by 1,5. It gives us 113, let's just leave 3 decimal places, newtons upslope. Right? Right, of course we don't really care for the direction, but yeah. Maybe let's take everything down so that we have our stuff all in one page. Wow, for 5 marks, guys, 3 steps, really? Icon, then we can use our friend. Yeah. So this is going to be F minus the sum of FG parallel plus FK is equal to MA, right? Now we know the force is 113,33 minus FG parallel is going to be 90. Oops, not 10. Gone are those days of taking the gravitational acceleration as 10 times sine theta. But now sine theta is opposite over hypotenuse, which is going to be 3 over 45, right? Plus FK is equal to 90 times 0. Sounds right to me. So this implies that our FK is going to be, remember we transpose this dude all the way to that side. Yeah, actually we don't, we just need FK only. So this is going to be 113,333 minus 90 times 9,8 times 3 over 45. Therefore, the frictional force is going to be the differentiath. Minus 90 into 9,8 times 3 divided by 45. 45. I get 54,53 newtons. Again, we were supposed to find the magnitude. We are not interested in the direction. So this was a crazy question. Certainly a higher order one. All right, guys. So yeah, I need to drink some water. I'm a little tired now. I've been doing the talking and is not nice. You see, yeah, it's nina. It's not mas. It's not na. It's not na. A bad thing happened yesterday. I cannot believe it. I really can't. But yeah, it's just taken me down a bit, a notch. But anyway, this is what we face in this life after all. But yeah, it's not okay. It's really not okay. Anyway, guys, so I would say this is good. This is good. The formula that answers the question, yep. Calculating our FG parallel, yeah. So 1, 2, 3, 4. And of course, it's a very crazy thing, I tell you. But yeah, this is what it is. So 14 marks. So again, guys, this is usually what we call the work energy thingies. Yeah. Work energy thingies. Otherwise, 14 marks here. Last question. Crazy. It's not only time consuming. There's not a lot of marks either. Anyway, guys, so that's it for those questions. Now let's get to question 6. Is the Doppler effect? Let's see. So we are told here that a traffic officer is sitting in a police car which is traveling at a constant velocity. Now the siren of the police car emits sound waves of frequency 1500 Hertz. Right, a detector that is placed inside of the road records a frequency of 1695. What is going on? See, I'm tired, guys. I'm not just tired, I'm down. Because of what happened yesterday. I won't say what it is, just for the sake of, the greater good. But yeah, it was a terrible thing. I don't know. Still ask myself how it happened. But yeah, it did. Anyway, so this is the case here, Doppler effect, guys. We're told here that the police car takes 1.5 seconds to reach the detector. Okay. So if we are given that, it means we're going to take stuff. So again, we are told to take the speed of sound in air to be. Can you see, guys, this piece right here? This piece right here can help a student to go and answer 1.4 in the MCQs. Because if you did not know what is a constant, now you know. So at some point, that piece can remind you if you couldn't answer that question on the MCQs. So those are some of the perils of, having full reviews of the stuff, It's not 1.4 actually. It's 1.7. Yeah. That was 1.7. Ngicabanga njalo, but again, I don't remember anyway. Yeah, I think 1.7 was the question on the Doppler effect. Anyway, but you see, sometimes you can play with this. Guys. You've got the answers within the paper. There's no excuse for failing. If you fail, well, it's because you choose to, right? Name and state the phenomenon described above. It's the Doppler effect. Right? Which states that this is an Okay, let me try to write nicely. An apparent change of frequency of sound when there is, or maybe we can say due, an apparent change of frequency of sound due to relative motion of the listener, or you can say detector, and sound source. Okay, it is an apparent change of frequency of sound due to relative motion of the listener and the sound source. Or you can say as observed by the listener. Yeah. It's an apparent change of frequency of sound as observed by the listener due to the relative motion of the listener and the source, or whatever. Hi guys, but it's an apparent change. It's not a true change, okay? It seems to be. It's not exactly doing that. Relative motion is important, so relative velocity issues need to be thought of here. They can horrify students who are careless. Right, so again guys, this one is quite wordy. So yeah, 2 marks here is good for this one and 1 mark for the thing. For the thing, okay, 6.2. We are asked to write down one medical instrument that makes use of the phenomenon. It's a Doppler ultrasound or ultrasound Doppler. Doppler ultrasound machine. Okay. Again, easy stuff there. So 6.3. Calculate the distance between the police car and the detector. As you can see, it's a 5-mark question, so it means first we need the speed of the source, because we are given the time it took to get to the detector. And since it's doing constant velocity, see that formula we just used above? And you see guys, when you play with things, let's say we were not able to answer this question right here. But as soon as we get to this one, we would get an idea about, that one. So please play with the papers, guys, and don't approach these with fear. Even if you fail, it doesn't matter. If the time for you is to fail, you will fail, whether you cry or you don't, whether you panic or you don't. And when it is time to pass, whether you are afraid or not, anxious or not, you will just pass, because all of these things come with what you did before the exam. If you prepared well, you are likely to make it, although you can still fail, depending on the circumstances surrounding your exam. But mostly, preparedness is always going to take advantage of the opportunity provided, right? Which a friend of mine said, well, there isn't such a thing called luck, is it? Because when someone is offered an opportunity, if they are not prepared, that will just pass them by. But when you are prepared and an opportunity comes, you just get it. Yeah, I have missed those opportunities because I got to those unprepared and I lost out. Imagine if I was prepared, I wouldn't have lost out. Anyway, so we're going to use our Doppler effect equation for this calculation. So we know that the frequency of the listener is going to be the velocity of sound in air plus or minus the velocity of the listener divided by the velocity of sound in air plus or minus the velocity of the source times the frequency of the source. The detected frequency was 1695 equals 340. Remember, this is moving towards the listener. So here we put a plus, isn't it? No, the listener is stationary, so we don't do anything, just leave it. And then here we will have 340. But now, for us to get a higher frequency, we need to subtract here the speed of our source times the frequency of the source, which was the original. Originale. What I hate about this calculation is just that it's crazy, man. It's really crazy. I don't like it. Ansayonqeni yonke le nto Nkosi yam. Ndiyonqena straight. Awayibona le nto. But let's do it this way. This is going to mean 1695 divided by 1500 is 340 divided by, like this. This implies, let's reduce that because I don't like these big numbers. So 1695 divided by 1500, we get 1,13. Then into, when we cross multiply, 340 minus Vs is equal to 340. Isncada ihudes isnca. Yo, kumsebenzi lento. Inkomlela lanta. Inamadla lento. Ivalelwe kaphakathi kwami. Anyway, we fall this out, we get 384,2 minus 1,13 Vs equals 340. So we can say this implies that the velocity of the source is going to be 384,2 minus 340 all divided by 1,13. Therefore, the velocity of the source, we subtract 340. Of course, guys, there's many ways of dealing with this calculation, but I just chose to do it this way. You know, this one is 39,115 meters per second. We can say then, we know that this is the case. This is 39,115 times, we're told this is 1,5 seconds. Okay, so times 1,5. This is 58,67 meters. Interesting stuff. So this was a nice question, actually. I like it. This is how it should be asked, than just the basic classwork That is often asked, okay? When things are made to look a bit interesting, it's very nice, it's good, it's perfect. But when people are doing their people things, you know, we let them be, you know, we let them be. Nice. Okay, folks, we get a mark for the stuff, substitution, and the technical answer. The rest of the gymnastics, ain't nobody interested. This is the last 2 marks. Straight into BS. Yeah, that's 5 marks. Okay, the question says, draw a graph of frequency heard by the traffic officer sitting in the police car as it moves towards and away from the detector versus time. Really? Draw a frequency heard by the traffic officer sitting in the police car. As it moves towards and away from the detector. Guys, this is crazy. Indicate the frequency on the graph, which is the frequency heard by the traffic officer, the time taken by the police car to reach the detector. This is crazy. Why nisibuza le nto nisibuza yona? Nisibuza inyongo. Anyway, a graph of frequency versus time for the office. Ndikhathele ke guys, niyibone writing yami icimela nje. A graph of frequency versus time for the officer. All right, we can just say that. And of course, this is going to be frequency in hertz, and this is going to be time in seconds. Of course, guys, this guy is gonna hear a constant frequency straight up all the way. So as he moves towards and away from the detector, okay, maybe let's say this is up until the detector. So this was 1,5 seconds. He will hear the same frequency even when he himself moves away. So guys, I don't know, this question is crazy, like seriously, I don't get it. It's crazy. Anyway, the shape and the rest of the stuff. Great. So how many marks here? 11 marks. Right. Okay, let's get to electrostatics. It's one of the silly topics, actually. Electrostatics is easy. In fact, it bores me to death. I don't know why. This topic really bores me 100%. For some reason, it just does. Just like the Doppler effect. It doesn't make me excited. Yeah, I know I'm not excited by a lot of things. Anyway, we are told here that 3-point charges X, Y, and Z with charges minus 3 microcoulombs, plus 6 microcoulombs, and plus 9 microcoulombs, respectively. Now everything is indicated. are placed on insulated stands. So what does that mean, or what is the use of insulated stands mean here? Remember, we say charge cannot be destroyed or not created, and what? Is it charge or is it energy? I think it's charge. Charge is some form of energy, is it not? Yeah. So basically, we're just trying to say the total amount of charge in an isolated system. So the insulation creates an isolated system in a way. I hope so. I believe so. But I could be wrong. Anyway, state Coulomb's law in words, and you guys know this, right? Now I'm bored. Okay, we know that the electrostatic, okay, let me write better. Let me just take my time to do this one. We know that the electrostatic force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square square of the distance between them. Okay, a bit wordy. This one should be 3 marks, same as Newton's second law. This is literally the same thing, except that one uses charges, this one uses Newton's laws talks about, motion, even that of universal gravitation as well. Those ones should be 3 marks. They're a lot wordy. Anyway, guys, the key here is the direct proportionality and the inverse proportionality here. So that's the one. Okay, 7.2, we need to calculate the net force acting on point charge Z. This one is being repelled by the 6 Coulomb and it's being attracted by the -3 Coulomb. So yeah, this is indeed interesting. Okay, all right, okay. So the resultant force here is going to be the force between these two minus the force between these two, right? Yeah. So I'm going to do it. So the resultant force is going to be K Q1 Q2 over R squared minus K Q1 Q2 over R squared. Coulomb's one is 9 times 10 to the 9. Is it so? Let's check. Yes. Okay. So this is the first charge, which we don't care now about their sign. It's 9 times 10 to the -6 times 6 times 10 to the -6 all divided by the distance between these two is 10 centimeters. So we convert that to meters. So 10 divided by 100 is 0.1. So we will subtract 9 times 10 to the 9 of 9 times 10 to the minus 6 into 3 times 10 to the minus 6, all divided by, now this is 15 centimeters, divided by 100 is 0.15 squared. Right, so let's put it onto the calculator. Great. So we will have here 9 to the 9 into 9 to the minus 6 into 6 to the minus 6 divided by 0.1 squared. Right. So this one gives us 48.6 minus, we do the other one. So this is 9 to the 9 into 9 to the minus 6 into, I didn't do this right, 9 to the 9 to 9 to the minus 6 into 3 to the minus 6 divided by 0.15 squared. So this one gives us a 10.8. Therefore, our resultant force is 37.8 newtons. Now remember, it said resultant force. This is going to be to the right. Remember, vectors must be treated with respect. You need to know who you're talking to. If you're talking to your peers, well, you are good. So this and that. How many marks here? 5. Why? Okay, 2 marks for the answer because of the direction. Yes. That's easy. 7.3 says, point charges X and Y are brought into contact, then separated. Okay. So, actually, I shouldn't say 1 and 2 here. There's no 1 and 2 here. This is Z and Y. Right, so this is Z and X. Okay, so X and Y are brought into contact and then separated. Now we're told here point charge X is returned to its original position while point Y is removed. Okay. So in which direction did electrons flow? Okay. Now which one has more electrons? The one with the negative charge, right? It has an excess of electrons. And the one with the positive charge actually is having a deficit of electrons. So the electrons moved from X to Y, right? It makes sense like that. So 7.3.1 is going to be X to Y. It's supposed to be like this. But again, you should know this all already. Yeah. Yeah. Yeah, you're right. Oh, I want to pale kabi. Funa ndimbhale nge-capital letters. Wabona mos, wabona lwena. It must or can be. It must or can be. Is there such a thing? Well, I'm making it to be there. 7.3.2 says calculate the number of electrons transferred to or from point charge X. Okay. Now, to know the number of electrons transferred, what we need to know, we need to first calculate the charge that remains, right? And so the charge that remains is going to be those two charges added together, and we divide by 2. Then we use our so-called quit equation to sort this out. Ne? I believe so. But is it going to be just a quit equation like that? I'm thinking now, how many marks is this? 4 marks. Yeah, it's not that easy, eh? I think we need the resultant. In fact, we're going to say initial minus, it's going to be final minus initial. Yes, I think so. It's going to be final minus initial. And then we divide that by charge on an electron to get the number. Let's put it to work. First of all, we want the charge, the resulting charge on our X, because since we're talking about X, so we can say the final charge on X. I will put it that way. So we can say X final is going to be those charges X and Y. So it's minus 3 times 10 to the 6 plus 6 times 10 to the minus 6, divided by 2. Therefore, the final charge on X, let's put it on the calculator. So this is minus 3. Here you write it as it is. Plus 6 to the minus 6. Divide that by 2. So I'm getting a plus 1,5 times 10 to the minus 6 coulombs. Okay, so this means the resulting charge is a positive charge. We can say then, we know that charge is equal to, what am I saying? What are we doing here? Number of electrons. Ooh. So we can say number of electrons transferred. It's going to be the initial charge, final charge minus initial charge. So I am thinking final is 1,5 times 10 to the minus 6 minus the initial charge. What are we going to do now? Are we going to add? Image, guys, think. Siyangeza noba senza ntoni apha. Wona ingqondo yami ibhidekile, strong. But I think we should just put it as it is, ne? Alright, let's try. You will guys check the memo if ndiyabuda. Andikho confident nam apha ngoku. Sentenze zomqalamba fethu, hayi nanizongixolela yabona mos. No, yaxoka to the minus 19. Ne? So therefore the number of electrons transferred. Abafethu nizoyisheka sengikhohliwe ukuthi fanele ngenze njani nami. Yabona nami bafethu phela ndikuba umuntu uyabona. Ke ndizibhale zomqalamo yaqonda. Ke ndizibhale zomqalamo nami. ayitsho loo nto ukuthi ndikuqesta yabona ndikonqesta wale nto 2, I ndithola lena bafowethu and to 2 decimal places yiyo nje times 10 to the 13 electrons. Wrong or right? I am closing lezozo, ndilivalile, ngiyivala lezozo, so yeah. Khona into endibhidisayo kancinci apha, andikho sure uba ndibale zona, kodwa I know this one is gonna give us 2 marks. Uyafumana. If this is right, we get a mark in the final answer, you know. Kodwa ke bafethu, you go and check on the memo. It's actually in this paper, but sinaxesha lalokubhanqa lobo. Nani nizozijongela ngexesha lenu. Kanako yalina wabona. Now it says point T is placed between charges X and Z. By the way, who was removed here? Y. Okay, so point T is placed between X and Z. This is after this manipulation. We need to calculate the distance between point X and Z where the net electric field is equal to 0. By the way, this will always be a question. This question is always there, and it's usually not so friendly. Remember, the electric field is a vector, so we must think about it. Okay, let's just do it here. So 7.3.3. Now, we want this electric field to be 0. So we know and understand that in any case, these charges will now repel because there's going to be 1,5 times 10 to the 6. And then there's plus 9 times 10 to the minus 6 coulombs. Now we've got T between them. So these ones are repelling each other. So the force to the left is because of Y. No, because of Z. And this one to the other side is because of the other one. So we want to know what is the distance between X and Y. Okay, it's not a big deal. We know that the electric field what do we use for electric field again? Is it capital letter E? I think so. The electric field is going to be equal to, well, the one that's supposed to be, I don't know which one is big and which one is smaller. Nobody cares at this point. All we know is that these are opposing fields. But now, let's see. E is equal to KQ divided by R squared. So E is directly proportional to the charge. So I would suppose we can assume, although it depends on the distance as well, we can assume that the one due to Z is going to be bigger. So it's going to be KQZ over R squared plus, or they are opposing, so it should be minus KQX over R squared. So we were told that the resultant is a 0. So this is 9 times 10 to the 9 into 9 times 10 to the minus 6 divided by R squared minus 9 times 10 to the 9 This time it's 1,5 times 10 to the minus 6, all divided by r squared. But my problem here is that we cannot have r squared and r squared. You know, we are not at liberty to do that. Now we need to think about it. Remember, the distance between them is still 15 centimeters, right? So if we call this one x, the other one is going to be 15 minus x. So we can do that. Say if we call this one x all squared, this one in terms of meters is 0,15 minus x all squared. Okay, I think that was the trick with this question. Now we can see what's happening. Let's move a1 here. So this is 9 times 10 to the 9 into 1,5 times 10 to the minus 6 is equal to 0,15 minus x all squared equals 9 times 10 to the 9. And yes. Now, because we have got squares, we don't want problems. So let's start a square root. Be quadratic. When we can avoid the quadratic, we just avoid it. So this implies, now we have the square root of 9 to the 9 into 1,5 to the minus 6, basically. So I'm going to take it as it comes out. So this is 30 root 5, no, 15 over, this one comes out as it is. Okay, I don't like the drifting. It's not quite impressive. Move closer. Hatamela mona. Udlule hore ke ja batho nna. O sompalea tjena. Tshwanetse re njwetse. Re boetsalang. Ha ke je batho nna. 90 root 10 divided by x. You see, this one comes out nicely. So we just cross multiply now. We'll never have a situation. So we will see that we will have 30 root 15 x is equal to 90 root 10 x, wait, no. So let's say 0,15 times that 1. So I will have to round off. So this gives me 42,691 minus 90 root 10 x. All right, so this implies that we add the x values together. So we've got 30 root 15 plus 90 root 10. All right, so this one gives us 400,794 x equals 42,691. So we know that therefore x is gonna be, oops, the calculator wants to fall, so I'm gonna say 42,691 divided by 400,794. So this to two decimal places is 0,11 meters. When I am okay. Now, but now what is the question here? What is the distance between t and x? So if the distance between z and t was x, we can say therefore distance between x and t is going to be 0,15 minus 0,11. Right, which is equal to 0,15 minus 0,11. So this is 0,04 meters. As you can see, point T is very close to it's very close to charge X than it is to the other charge. Anyway, anyhow, so this is one of those silly questions, guys. It's nothing but algebra, you know. It's just algebra at its best. So we just have to deal with this as best as we can. So we can say mark for formulae, this substitution and that substitution. Hey, 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 hey. Hey, ingathi kusiwe nje. I-4 marks, cha bafethu. Ayingeke. Icon. I'm not happy with these ones. These ones, no. We can give them 1 mark, but the X value deserves a mark. This should have been 5 marks. Can you see, guys? Get a lot of marks above for definitions that are worth 1 mark, and we constrain or we strain a question where marks should really be given, because there's lots of issues that deserve marks there. Anyway, guys, yeah, that was a nice 16 marks. But this topic really bores me. I don't know why. I never really had. In fact, if there's any topic on electrostatics that made me excited, was the Millikan's experiment related questions. They were made to be very crazy. I loved those questions, and you must have seen that on our 2005 question paper that I showed you. Yeah, questions there were crazy. One had to couple Newton's laws of motion together with electrostatics. That was fun. Anyway, it doesn't matter. Gone are those days. Now we did this one, guys. Do you really want me to do it? For the sake of finishing this question paper, in case someone did not see did I mark this one as question 7? Okay, I did. in case someone did not see that video. Now the battery in the circuit below has an EMF of 12 volts and internal resistance of 0.30 ohms. The resistance of the connecting wires and ammeter can be ignored. Okay, sometimes the term negligible is used. So we know that, well, the long bar is the positive terminal, the shorter bar is the negative terminal. And then of course this unit is a cell. This means this is a 2-cell battery. Now in a household you can think about what could use 2 cells. Yeah, whatever. Now this could be a remote controller, you know. Or a torch. What else? Okay, let's not waste time. This one says we need to state Ohm's law in words. And by the way, the current is traced this way. Conventional current is from the positive terminal all through the circuit, where we will have a branch into that portion of the current and that portion of the current. But then we will have to see which one is bigger. This is 7 against 13. So that branch on top is going to get a smaller current than the one below. Right, let's talk Ohm's law first. Well, we know that the potential difference between 2 points of a current, of a current carrying conductor, the potential difference between any because it's not just a specific 2-point thing, it can be any 2 points. Okay, between any 2 points of a current carrying conductor is directly proportional to the current in the conductor, provided the temperature is kept constant. Again, it's a very wordy definition, so 2 marks is okay. But this is all about this direct proportionality while the temperature is maintained, because temperature in effect is a surrogate for resistance in this scenario. 8.2. Determine the total external resistance of the circuit. Easy. 8.2.1. We know that R parallel. We often say product over sum. I mean, there's many ways of doing it, but let's just do it the standard way. We say 1 over R parallel is going to be 1 over R1 plus 1 over R2. And this often goes on as long as it wants. So this is 1 over R parallel. It's going to be 1 over the sum of the top. So that's going to be 8 plus 5. You can just show this to convince someone that you know what you're doing. And then here you can just go for the jugular after that. R parallel is, okay, all right, okay. Now, we just jot the answer. Who cares? It's just 3 marks, folks. So this is 13 and 7. So 13 times 7 is 91. Ne? I'm thinking now. Eish bafethu sendiyibhuda ke ngoku le nto andisazi uba ndenza ntoni apha. Let me first do this. 1 over 13. Let me just do it on the calculator and stop struggling, because now I'm wasting time. This is 91 over 20. So this is going to be 91 over 20. So yeah. 91 divided by 20. This is 4,55 ohms. Great stuff. So folks, formula, substitutions, answer. Easy. 8.2.2. The reading on the ammeter, which is the total current. Okay, this is easy. We know that the EMF is going to be equal to the total current, R parallel plus the internal resistance here. So this is 12 into I into 4,55 plus 0,30. Therefore, I is going to be 12 divided by 4,55 plus 0,30. This gives us a 2,47 amperes. Okay. Again, substitute this, adjusting. The current through the 8 ohm resistor. Okay, so this is easy. We can do it in style or do it normally. So we know that the resistors in parallel, the ratio of resistors is going to be 13:7, right? This implies that the ratio of current is going to be 7:13. It reverses that. You can see this implies that the current through the 8 ohm resistor is going to be the 7 portions of those 20 portions. We add those two, we multiply by the total current. Okay, so we've got 7/20 times 2,47. So the answer here is 0,86, let's say 5 to 3 decimal places, but I mean it's terminating. You can write it all, 8645 amperes. Okay, so that looks okay. Again, guys, one can still use the R parallel and the total current to find the voltage across the parallel resistors, all of them. Then take that same voltage and divide it by the top branch of resistors together to get that current. It should be the same. All right, good. But sometimes you've got to learn different techniques, because certain questions may only be solved by this technique of ratios of resistors to get around issues. So you've got to be flexible. But standard approach, you can do it, guys, even if I didn't show you. Ne? So 4 marks, yeah. This is good. This is good. This is good. Yeah. I don't know, guys. Maybe that, or even that. Cares. The marks are in the bag. Okay. 8.3 says 2 voltmeters V2 and a very high resistance. The voltmeter V2 with a very high resistance is now placed between points X and Y, as shown in the diagram. So there it is, okay? We need to calculate the reading on V2, because the V2 is going to read the potential vertically across those two, okay? So this could easily be this voltage and the voltage there. The difference is what we can do. Or it can be the voltage here versus the voltage there. Again, those two will give us V2. So that's just the idea there. So all we need is just the small voltage over the 8 ohm and the 4 ohm. Or we can use the 5 and the 3. Whichever you choose, it's up to you. So we know that V2 is going to be basically the V over the 8 ohm resistor minus the V over the 4 ohm resistor. But then we're not sure which one is going to be bigger, but the bigger one is going to subtract the smaller one. So I'm not sure what's cooking there, but we're going to just go for it. V2 there is going to be IR, isn't it? The current there is 0.8645 into 8 minus the current is going to be the total current here, which is 2.47 minus 0.8645 into the 4 ohm. Whether it comes out negative, it means we inverted the equation. If it comes positive, then it means we did it okay. 0.8645 into 8 minus into 2.47. Was it the total current? Yes. Minus 0.8645 into 4. Okay, it means we did not invert it, so I'm getting 0.494 volts. Nice and easy. Okay, so this is not too complex, guys. It's a very simple calculation. Again, these are the old type of questions. If you don't know this, you probably froze. And I know most of the students who wrote this paper unprepared lost these 4 marks at least. Those who are smart, who can put up a fight, probably got some marks. But because of not understanding what to do, probably didn't get to the final answer. But those who, when they are told what to do, and who told you what to do is me. I told you. When I showed you that November 2005 question paper, it was a hint that go look for those old question papers. Ask your teachers, if you can, to find you as many of those old question papers as they can, because some of them have even access to those old textbooks and study guides that we used. If I can cite one guy, there was something called Star Schools in Gauteng, which was sponsored by the East Rand Youth Trust. They used books by J.M. Lucas. Those were study guides. J.M. Lucas, I think, if I remember well, that's J.M. Lucas. And in fact, at the Mall of Africa, if you go to one of the bookshops, I don't remember now whether, was it, I don't remember the name of the bookshop, but there's a bookshop there. Bookshop, not bookshop, bookshop. Go and check this, but again, you're going to find the modern ones or the recent ones. But if you can just contact the guy and ask him of his old thing, is if he still has transcripts and stuff, they can actually send them to printing. Might be expensive because they know it's an opportunity of a lifetime. So yeah, and if you are lucky, you get to the people who went to school in 2005, specifically doing matric, go and ask them if they still kept those copies. Usually you'll find them lying around in their homes or so. Check these kinds of questions. This is a typical question in those kinds of textbooks or study guides. In fact, those were study guides, not textbooks. Yeah, even the old textbooks, we used Brink and Jones, Physical Science in Action. I've been looking for that book. I can't find it anywhere. And I actually had that book because a friend of mine got me a copy. But my nieces, I don't know why, they keep playing with my books. I kept those books at home. They kind of gave those books away. Cannot find any of the books I kept, even most of my first year textbooks. I never sold them. I kept them there. Now I can't find any. And I was looking for some of those textbooks, but there's some things I need from those books. People don't understand. Knowledge never dies. It can only transform. But sometimes to understand the transformation, you need to know where it started. So I hate it when people destroy knowledge banks over just stupidity and ignorance. And I have a harsh word with my nieces over this. Anyway, this is the one, guys. So all I'm trying to say, don't look around you only, guys. Even look far back. Look where you came from. Look where all of this comes from. What type of questions were there and how were they solved? Okay. That way you will be prepared for anything. Yes, there is a chance for not knowing something. But can you imagine if you just did check this out, you would actually realize that you got yourself 100% on this exam. Anyway, let's not talk about fantasies here and wishful thinking. So this calculation, that calculation, and that's the one. That's the one. Okay. Try using this resistor. Try using that resistor and that resistor. Okay. And see what comes out. 8.4. It says when the 8 ohm and the 5 ohm resistors alongside X are removed, the reading on V1 increases. You see that last MCQ question? Typical of this stuff. Okay. It says now, when those are removed, the reading on V1 increases. Question is why? Right? Explain this observation. So why does it increase? But now V1 is the external voltage. It's the voltage of the external circuit because it's across the terminals of the battery. when there is a current passing or flowing through the circuit. So when there's a flowing current through the circuit, the voltage across the terminals of the battery reads the total external resistance. Voltage. Okay guys, so please, we need to know these things. There's no excuses for not knowing them. If you just go through these things without studying them, you got to study these things and know them for what they stand for, so that in dynamic situations you can follow the trends. So why would V1 increase? Guess what are we doing? When we cut this off, we literally are increasing the external resistance, isn't it? But now, since this one is inversely proportional to the current, the total current decreases. Right. Now, when the total current decreases, we then have to take things and put them together. So we know that I R external plus I plus internal resistance. Now we know that this and that are constants. So when I decreases, and we saw here R increased, so we couldn't just use this part alone because it's an up and down situation, so it wouldn't give us an answer. Just it was the case in the MCQs. But we see that a decrease in the current here will effectively drop the lost volts. From the same EMF, if we take less, there's going to be more available for the external circuit. So again, we're using Ohm's law, using the EMF equation. So again, you see, you are asked the same thing twice. Can you imagine if you couldn't answer there, but then it came back to you at 8.4? This already gives you an answer for 1.10 above. So this is why I'm trying to tell you guys that, look, make these things work for you rather than to just crash and burn. There's no need. Anyway, I'm sure you can see exactly what this is, but this time in the MCQs, we didn't have to put it in words. Now the challenge here is just that we have to put it in words. Okay. So we will say, according to the equation, right? E equals I R external plus, okay, maybe let's start talking about the current first before we get to this. We will just say, okay, the external resistance, the total external resistance, the total external resistance will increase with a subsequent decrease in the total current. Okay, that's easy because these two are inversely proportional. Right. So you may even use an equation for that fact, because for you to know this, it's because we know that I is inversely proportional to R. You see, there's no harm. When you want to show that you know things, this is the first bullet. Now we will say according to E equals IR external plus IR internal, or whatever, we will say that E and R are constants. such that IR will effectively decrease. Effectively decrease, resulting, oh, she's my student, I'm going to talk to her now, resulting to an increase of the external voltage, the total external. Which is V1, okay? I mean, there's many ways to put this, guys, but try your best. Sometimes it's not gonna be perfect, but if it is sending the message, why not? Just do it. You can never be too perfect for physics. Everyone is just a lawbreaker who keeps on trying. So we're saying that total external resistance will increase, right? With a subsequent decrease in the total current because of this business right there. I would give a mark for that. Now, stating that these two are constants, that should be a mark, such that this one effectively decreases. Maybe we can say this whole phrase up until there would be a mark, resulting in an increase in the total external voltage, which is V1. Okay, I don't know, guys, but it's just easy stuff. You find a way of saying it. And as you can see, if you compare how I answered this to the one that I did for the video where I only answered this question, you'll see that it keeps changing because I give my answers on the fly. I do not sit with some prepared answers and, you know, try to regurgitate them. No. And it's not because I'm smart, no. It's because I do not want to mislead you guys to making you feel like you are the ones with the problem. No, everyone has a problem with the science. And the science is a challenge even to the scientists. Those who have mastered it, they still have a challenge. There are lots of things that remain unanswered. So it will take you guys being at the level of those who have gone before you to discover new things or new ways of dealing with things. This is why here I'm trying to make it my best to give you a raw way of answering as you see the problem, and to actually play with the knowledge and the tools you have at your disposal to try and get around the point, you know. And if you make this a habit, guys, it becomes second nature. You don't struggle when you see issues of this nature to think of possibilities. At times it's a question you have never seen, but if you have what it takes to play with it, you will be able to construct a valid response. Anyway, let's leave that. So 8.5. 8.5 says the cost of energy is, 2 rands 59 cents per kilowatt hour. Okay. Now this is a topic from grade 11, so guys, go and revisit it. All right, how many 80 watt light bulbs can you have for 8 hours a day if your budget for lighting is 300 rands per month? Assume that an average month is 30 days. Okay, now here I do this mathematically or arithmetically, of course with some logic in there, but there may be a formula, guys, that you probably are aware of or that you have been taught in grade 11. I did buy some grade 11 textbooks, but I don't really read them unless I get stuck with something when I'm teaching. So yeah, I don't even know, I don't remember, and I don't care. But you should care. And you should remember. It should bother you when you don't know these things. So now it says, how many 8 dondoni must we put here? So guys, here's the thing. We need to know how many kilowatt hours can we purchase with 300 rands, right? Because if we can get that, you know, we will then need, okay, I need to convert those kilowatt hours to hours. You get it? Because if we can do that, we will get somewhere. We will get somewhere. Don't even remember how I did this now. Can you imagine this? So we can just say the number of kilowatt hours that we can purchase here is going to be 300 divided by 2 rands 59 cents, which is going to be giving us okay, let's do it. So this is 300 divided to 59 when so we get 115,830 kilowatt hours. Right? Right. So that's what we're gonna have. That's how many these will be that we can purchase. Yeah? Now we need to convert that to hours. We need to convert that to hours. Okay, maybe kilowatt to watt and hours. Ndiyacinga ke ngoba fanele ndenzeni. Sendilibele nanda ndiyenze njani lento. From this one, we're going to have to, I want to use this guy. You know. Okay. Okay, guys, those are the kilowatt hours for 30 days. Right? But then we can divide that with hours so that we can leave kilowatts. I mean, there are many ways of killing a cat, truly. So we can actually deal with this nicely and take those hours to 8 hours a day. And then we can get rid of, but yeah, okay, all right, okay. We can get rid of the hours and say what words can we have. So we can say here, then we can say also, we want perhaps the words, isn't it? So we can say the number of words that we can get is going to be this 115,30 times 8,000, right? Because from words to kilowatts we divide, but now from kilowatts to words we multiply by 1,000, and then we will divide this by 8 hours every day. So this is going to be 8 times 30, which is equal to, so we do this, we multiply that by 1,000, and then we divide this by 8 times 30. This gives us 482,625 watts. Right. So now we can say the number of bulbs. We can say therefore number of bulbs is going to be 482,625 divided by 80. Okay, we divide that by 80. We get 6. Now remember, number of bulbs cannot be with a comma, so we take the integer before the decimal, so this is going to be 6 bulbs. Nice and easy. So guys, you can just plan it your way, but you hoy everything at your very best. If you get a number that is reasonable, I mean, I'm getting 6, it's reasonable, it's not outrageous for what I'm given. So the approach may not be the same, but if the answer is good, it's good. Eh? So this dude, I suppose, is cool. This step and this dude, I think it's cool. And that one is cool. 1, 2, 3, 4. I mean, guys, whatever. If you do this, that could be 5. You can also consider that. Either way, it is good enough. Okay? Sometimes one can just give 2 marks here for the numerator and the denominator. You know, numerator, denominator, 2 marks. You know, say 1, 2, 3, 4, 5 for the whichever. At the end of the day, if we get the same answer, guys, we have full marks no matter what. So this closes our discussion, guys, for now. Now, matriculants, we need to start with our classes on Monday. Okay, I will communicate on the group. This time I mean it, guys, 7 p.m. sharp. Please, guys, try not to be later than 10 minutes if you can. I beg of you, so that we have less distractions. But if you can't, I mean, the situation sometimes in which you find yourself may not be so conducive. Any time is okay, but yeah. I would rather you all come in early so that you don't miss out on anything. And then we do our thing. Because, guys, you need to make use of these opportunities. They will not be always available. But yeah, while they still last, put them to good use. Otherwise, guys, this is my 2 cents contributions to your knowledge and learning. I do hope it makes a difference. Otherwise, I'll see you some other time. Goodbye.